Reward behaviors change recommendation strengths, so they're very influential on future behaviors and require very careful management. And a critical issue is the circumstances in which reward behaviors should occur in early life, and how these circumstances can be safely evolved through experience. Genetic information has to provide starting points, and also has to limit the changes to those starting points to reduce the chance of dysfunctional reward behaviors developing. One possible genetic specification is connectivity that results in receptive fields corresponding with certain facial expressions, which are effectively caricatures, for example, of a smiling face or a disapproving face. These receptive fields could have genetically defined connectivity onto reward components. So, if, for example, a smiling face was seen after a behavior, the receptive fields detected within that visual experience could have genetically specified recommendation strengths in favor of increasing the recommendation weights of the receptive fields that recommended any recent behaviors. Genetic bias on connectivity could also define receptive fields corresponding with caricature body positions and links from those receptive fields to reward behaviors. In both cases, these receptive fields are detected within visual information, but genetic information could also define receptive fields within somatosensory information corresponding with receiving a hug, or within auditory information corresponding with certain tones of voice. Tastes or smells could also be genetically programmed to connect and have recommendation strength into reward components. There could also be genetically defined connectivity from the areas in which these receptive fields are detected to a cortical area that detects combination receptive fields. And this reward area could heavily target reward components. In fact, in some cases, the genetically defined facial expression, body posture, and so on receptive fields could be located in this area from the start. There could be genetically defined bias on certain other areas also targeting this reward area. And that would mean that if heuristically defined receptive fields in these other areas were detected at the same time as the genetically defined receptive fields in the reward area, they could become part of the definition of the reward recommending receptive field. And it could even be possible for, in some cases, for those other areas to target reward components directly, although that might carry some higher risk. But what would happen is that initially those connections would have zero recommendation weights, but if a receptive field in that other area was often detected when the reward component was active as a result of genetically defined inputs, the receptive field in the other area could acquire recommendation weight directly in favor of the reward behavior. Remember that, except for reward behaviors, any behavior is implemented by release of receptive field detections from the senses into a cortical area, between cortical areas, or out of a cortical area to drive motor movements. A detailed behavior is release of receptive field detections from the motor cortex. A tactical behavior could be release of receptive field detections from other areas into the motor cortex, or perhaps the supplementary motor cortex. While a strategic behavior could be release of receptive field detections between areas only connected very indirectly with the motor cortex. And the management of rewards for strategic, tactical, and detailed behaviors depends upon connectivity biases established under genetic control, the spiral of connectivity from the cortex to the striatum, on through the midbrain dopamine neurons that implement rewards back into the striatum. Strategic rewards are recommended by higher cortical areas like the area numbered 24 by Brodmann, and are implemented through the shell of the ventral striatum to influence strategic behaviors, but also to reward the rewarding of more tactical behaviors. In other words, a strategic reward rewards the rewards that were recently used on more tactical behaviors. and so on, with the reward behaviors that reward the most detailed behaviors being themselves rewarded by the rewards applied directly to tactical behaviors.